Okay, so a few more words about the kinetic theory of matter. I have been thinking about this for the past 3 or 4 hours, and I'm sitting here in front of music school just waiting for my son to finish his lesson. The kinetic theory of matter doesn't stand as a theory of its own. It is supported by other theories, and it kind of clicks together with other pieces of thoughts and ideas that scientists have come up with before and have tested it, and it seems to be working. We haven't found some kind of contradictions to this. So this kinetic theory of matter has its feet or its roots grounded in theory that talks about how electric charges behave. That when you put two like charges, for example 2 protons or 2 electrons close to each other, they will repel very much. They will be repelling each other. And when you take opposite charges, the charge of a proton and an electron, so if you take proton and electron and you put them close to each other, they will be attracted to each other, and these forces of attraction and repulsion between electrical charges, they are called electrical forces, and they are very, very strong. And especially when these charges are close to each other, these forces are enormous. They are very big. And of course, protons and electrons, that's what makes up the stuff of atoms. That's what atoms are built out of, these elementary particles, which have these charges, electrical charges, and they're attracting and repelling each other. And so when you take these atoms and you put them close to each other, they will be feeling these electrical forces. So we say that atoms are on the outside neutral because they have just as much positive charge as neutral charge. But because the atoms actually have a certain size, and when the atoms are so close to each other that the size of the atoms now matters, so meaning that if this atom is facing this other atom with a certain side, then the attractive force is stronger than the repelling force, then the two atoms might be feeling a little attraction together. But if they are facing each other so that the electrons are facing each other, they will be repelling each other. And because they're in constant motion, it's this constant tug of war, constant attracting and repelling. And of course in solids especially, these atoms are very, very, very close to each other, and so they are feeling these forces of attraction and repulsion very much. And the whole idea behind the behavior of solids, liquids, and gases has to do with how these forces, how they are related, or how the effect of these forces is related to how fast the atoms are moving, or the molecules, how fast they are moving. Of course, motion, the kinetics, that's why we call it kinetic theory. So imagine something that's moving very, very fast. It's booking, like the atoms in gases. As these two atoms are moving at extremely high speeds, again we're talking about hundreds of meters per second, even kilometers per second. At these speeds, when these atoms get close to each other for a fraction of a second, if they're kind of just not on a collision course, just passing each other, they don't really feel these forces of attraction and repulsion because they're going so fast. It's kind of like when, I don't know, maybe you're hungry and you're passing by your kitchen, but you're in a hurry, you're going really fast, you have to be moving, you're running, and you are hungry and you kind of feel attracted to the kitchen, but because you're moving so fast and you're in a hurry, you have to go somewhere really fast. That force of attraction that you feel toward that kitchen is just not strong enough to stop you and to make you go into the kitchen. Okay? Or maybe if you go there, you just go there for a second, you grab something and then you run again. And or again, you're in a hurry and you just catch a glimpse of your favorite TV show. And had you had time, if you were not in such a hurry, maybe you would have slowed down or even kind of just sat down and watch your TV show. But because you're going so fast and you have to be moving fast, you will not stop and watch the show. The same thing for the molecules in gases. They are just moving too fast for the forces of attraction and repulsion to have any effect on them, other than for the cases when they are on a direct collision course, in which case, if they are on a direct collision course and they get very, very close to each other, of course, the electrons will be repelling the electrons of the other atoms so much that it will be a collision. And in that collision, basically, the collision is the force of these electrons pushing the electrons of the other atom away. And these collisions are interesting in that they are elastic collisions. No energy is lost to sound or to somehow deforming the atoms. They're elastic collisions. And this explains why, when you put something that smells nice in one corner of a room, soon enough the whole room will smell, because these atoms of gas are moving so fast that they can travel, and they're traveling freely. The forces are not keeping them bound to a certain position. Whereas in solids, the atoms are moving slow, very slow, and there are so many of them. They're close to each other, so that these forces of attraction and repulsion are now, their effect is very big. It's very strong on the atoms in solids. And in liquids, the speed is kind of intermediate, and so the forces are not strong enough to keep the molecules in the liquids from somehow moving. They can still move and pass by each other. But once the molecules in the liquid try to get far away, the forces of attraction from the other molecules bring it back. And so molecules or liquids have a definite volume. They have a definite volume, maybe not definite shape because the molecules can move, but definite volume. And in solids, they have also definite shape because they're moving so slow that as soon as they get a little further away from those natural positions to which they seem to be bound, the forces of attraction from the atoms on the other side, let's say I'm moving this way and ahead of me there are some atoms, and as soon as I get really close to them, they repel me back. And as I get back, the atoms behind me push me forward. And so it's this constant tug of war, it's this pushing and pulling of these electrons and protons on each other, mostly the electrons. And the interplay between how fast, how energetic these particles are, and these forces of electricity in between them. We call this kinetic theory, and as I'm saying, it has its roots grounded in the theory of electricity and magnetism, the fact that the charges repel and attract each other.